We have a kid throws a ball at a 36-degree angle on flat ground. If it lands 17.4 meters away, how fast did he throw the ball? So like usual, we can start with our angle. And so our drawing of our angle. And so basically what's happening here is the kid throws the ball at an angle at some velocity that we don't know. In fact, that's what we're going to try to find out. And the angle he throws it at is going to be 36 degrees, which we can draw, or at least note right there. That would make this velocity our hypotenuse. This would be our opposite side, and this would be our adjacent side. And our opposite side is going to be our Vy naught, the initial velocity in the y direction, and our adjacent side will be our Vx naught, our initial velocity in the x direction. There's a couple of things we need to know. First of all, the whole point of this is to find out what is the velocity. What is that going to be? And a couple of things to note is, of course, the acceleration in the x direction is going to be equal to 0. And we are given a couple of things. We're given our angle of 36 degrees. And we know that the delta x, the change of position in the x direction, is equal to 17.4 meters. The other thing to know is that the path of the ball is going to follow your usual arc, and it says it's on flat ground, so that means it's going to sort of land in about the same height as it began. So what we can surmise from that is that at this point our Vy, our initial velocity in the y direction, will be equal to, but in the opposite direction of our Vy here at the end. So we could kind of summarize that, I suppose, by saying that our Vy is going to be equal to our Vy naught. I'm sorry, our negative Vy naught. And that goes back to the thing about thinking this through. So that's just one of these things that you have to realize, and you think it through a little bit, and you get this. So this is not necessarily something I would always write down at the beginning, but it's something you want to keep in mind. So let's just start. We have our x's and we have our y's, and you should be suspicious right now because it is true that our x's are going to be somewhat lacking, and we're not going to have a lot of them, and the same thing with our y's. And basically what we can do is we look at our x's, and we know that the x change in x is Vx naught times time plus 1/2 ax t squared. And because the acceleration in the x direction is 0, we can just right out of hand eliminate that. And like usual, what are we going for? What are we going for? We're going for time. Okay, so I'm going to write that. In fact, I'm going to write that in big, like time. Find time. In fact, what is it? So we should be finding that first. Okay, what is the time that this ball is going to spend in the air? So we rearrange this, and we got that out of the way. I'm going to just rewrite this a little bit more cleanly to help us to see the math. And we want to find time, so we're going to divide both sides by Vx naught. So time is equal to delta x divided by Vx naught. Okay, great. So let's plug in our numbers, shall we? So we got time is equal to delta x. Delta x is 17.4 meters. 17.4 meters, and our initial x velocity, all we got to do is take the cosine. Oh, we can't. We don't have velocity. So what we're going to do is we're going to write what we can do. So we know that our it's the adjacent side, and so our Vx naught will be equal to V times cosine of the angle, which is 36 degrees. All right, but that's as far as we could go with this. This is unanswered. We have a variable here, so we now have two variables in our little equation. Let's see, maybe we went down the wrong path. I don't know. We'll try this with our y's. And in fact, what do we have? We have, well, we've got, we can probably, no, we don't know the distance, so this is not going to be the correct equation to use. Let's just go with this one. We definitely don't know how high it's going to be, but we want to find time. And so I'm going to choose the equation that lets me find time the easiest, where I think I could get as many variables as I can. Again, we're thinking this through. You know, it's a time, it takes time, and so it takes practice and familiarity with the equations. But this is probably going to be my best bet to find time. I could fairly certain I'm going to know negative 9.8 meters per second squared will be AY, and we'll see what happens here. We kind of already talked about that over here. So I want to find time. I want to put this in terms of time. So here's what I'm going to do. I'm just going to subtract. I'm going to say, let's see, AYT is equal to VY minus VY naught. All right. Now, we kind of, like I said, dealt with this up here. And so if we just take that idea and we replace it, maybe that'll be helpful, because we don't have the initial velocity in the y direction. And we're going to run into the same problem as we did over here. We certainly don't know how fast it's going at the end. So we'll just take this idea that we had over here, that the initial velocity and the final velocity are going to be the same except in opposite directions. So what that leaves me with is this. AY times t is equal to, and here I'm just going to substitute Vy for negative Vy naught minus my Vy naught. And so I'm going to simplify that a bit. AY times t is equal to negative 2 times Vy naught. So just to kind of take that over here, just to leave some room later. So t is equal to, so all I did was, I want to solve for t, so I'm going to multiply both, or I'm sorry, I'm going to divide both sides by AY. So time is equal to negative 2 Vy naught divided by my AY. Okay, great. So we got this solved in terms of time. So let's plug in what we do know. And we don't know a lot, unfortunately, but we kind of think about that. Well, I got a path. I'm going to show you the path a little bit in a little bit. So let's just plug in what we do know to negative 2 Vy naught. And we obviously know that this is negative 9.8 meters per second squared. Okay, we've got some numbers to deal with. So what I'm going to do, I'm just going to sort of deal with this. I'm going to mark it as if I'm canceling them out, but all I'm doing is going to say, all right, basically I'm simplifying this. That's the term I'm looking for, simplifying this. So fortunately, that also gets rid of our negatives. Vy naught over 4.9 meters per second squared. Okay, so what we got here is our time is equal to Vy naught, kind of butchered that a little bit, over 4.9 meters per second squared. We still don't have the actual number, but here's the thing. If you remember, we got time in the x and we got time in the y, in terms of things in the y. These are going to be the same time, because for as long as it takes to go from side to side horizontally, to go from here to here sideways, is going to be the same amount of time that it takes to go all the way up and all the way down. So it's the same time. So that's kind of cool, because then all we got to do is set those equal to each other. So time is equal to time. Time going across or horizontally is going to be equal to the time going vertically. Perfect. Well, maybe. Let's see what we get. So we're going to set those equal to each other. So let's use green. So I'm going to do 17.4 meters divided by V times cosine of 36. Probably solve that out. And now it's going to be equal to the other one. Vy naught is actually, let's just kind of complete this. What is Vy naught? That's going to be the opposite side. So that's going to be V times the sine of the angle 36 divided by 4.9 meters per second squared. Now you could simplify this anytime you want to. What I'm going to do is just sort of carry this over here and simplify it in a few minutes. It doesn't really matter when you simplify it. So V times sine 36 degrees divided by 4.9 meters per second squared. Okay, so let's start to sort of clean this up a little bit. So I'm just going to multiply both sides by 4.9. So 4.9 meters per second squared, that should cancel that out. And whatever we do to one side, we have to do to the other. So 4.9 meters per second squared. And so what that leaves me with is, well, the unit's going to be interesting, but 85.26 meters squared per seconds squared divided by V times cosine of 36 degrees is equal to V times the sine of 36 degrees. All right, well, we're getting somewhere, we're doing things, so that's always a good sign. I want to clean this up over here too, so I'm going to multiply this side by V times the cosine of 36 degrees, cancels that out, and we will just do the same thing over here, V times the cosine of 36 degrees. And what that leaves us with is V times sine of 36 times cosine of 36. So all I'm going to do is, I've got my 85.26 meters squared per second squared is equal to, I'll just multiply my unknowns, my variables, and I'm going to actually now multiply sine of 36 times cosine of 36 and get an actual numerical answer here. So I'm tired of dealing with functions, and it's a kind of a crazy decimal, so I'm going to put it in a bunch around at the end. 5, and it does keep going. All right, so where are we at now? We need to get V squared by itself, so I'm going to divide both sides by 0.4755, and when I do that, I get 179.30. There's no units over there, so it stays meters squared second squared equal to V squared. Kind of saw this coming a mile away once I saw the meter squared second squared. I don't want the velocity squared, I want plain old velocity. So I'm going to take the square root of one side, take the square root of the other side, and that, bring that over here, will leave me with a velocity that equals 13 points, let's just round it to 4 meters per second. Put a box around that because that answers the question, how fast did he throw the ball? So there was a couple leaps of logic, not leaps of logic, but logical steps you had to follow and think things through. These questions don't necessarily have formulas. The only thing I could say is find time. Okay, that's what you have to do. And how do you do that? Time is going to be your link between the y's and the x's. And so that should be your main goal. But you do have to consider, especially something like this. All right, it's going to go up and down, and velocities, we're going to be the same except negative. Little things like that you got to keep in mind. You just have to think it through. What is going on here, and what can I do next? If you go down a dead end, so be it. Then just turn around and try something else. There's no set lockstep process to follow. It's just try different things, and when something works, it works, and then you're good. So keep at it. Don't give up on this stuff. You're going to get it.